Let us see how SR flip-flop output will be generated. So output of the SR flip-flop, I'm going to denote it as Qn plus 1. Please remember that PPM signal is given to R input and reference pulses are given to S input of the SR flip-flop. Every time, the very first pulse that will occur in every cycle is the reference pulse, because PPM pulse will occur after some amount of time. It has to occur at different position. So very first pulse that occurs is always the reference pulse. So whenever the reference pulse occurs, that means S input becomes 1, and when S input becomes 1, in the beginning you can see that S will be 1 and R will be 0. And because of that, output of the SR flip-flop will become logic 1, and hence it will go to some positive level. After that, you can see the reference pulse will come down to 0, that means S will become 0. But R is also 0 because there is still time for PPM pulse to start. So when S is 0, R is 0, we know that output of SR flip-flop will not change, and hence it will continue to remain at positive level. The moment PPM pulse occurs, S is now 0, but because PPM pulse occurs, R becomes 1. And whenever PPM pulse occurs, at that time instant, you can see that the output of the SR flip-flop has to go down to 0. It will get reset, so it will go down to 0. So we have got first pulse, and you can see the width of the first pulse will be nothing but the starting point at which the reference pulse is starting, at which the output was set, and the starting point of PPM signal. So the gap between the reference point and the starting point of the PPM pulse, which is also the position of the pulse, which is proportional to amplitude of modulating signal, it is that much amount that will be given to the width of the pulse. Let's verify it one more time. When the second reference pulse occur at this particular time instant, in this case now again S will become 1 and R will be 0 because there is no PPM pulse. So output of SR flip-flop will become some positive level, logic 1. After that, you can see the reference pulse may go down to 0 and R will also be 0. In that case, output of SR flip-flop will be maintained to high level. You can see whenever PPM pulse occurs, S is 0, R will become 1 now. So third case, and in that case, the output of SR flip-flop, which was held to a constant level, will now come down to 0. So in the next case, you can see pulse will start at this point. It will remain high up to this point, and then it will come down to 0. In the next case, pulse will start from this point and it will remain high till this particular point and comes down to 0. As we can see that as the position of the pulse in PPM changes, the width of every pulse at the output of SR flip-flop also changes. This is nothing but output of the SR flip-flop. And hence, what we have essentially achieved is the conversion from PPM to PWM. The last waveform is also the PWM, and then if I give it to PWM demodulator, it will give me the modulating signal at the output. So you can see PPM has a lot of advantages, that it has a constant width and constant amplitude, so the effect of noise is less. The average power transmitted in every cycle is also constant. But the problem is it's a little bit complex circuitry. You can see in case of demodulator, apart from that entire PWM block, PWM demodulator, we require a few more things as well. So it's a bit complex in terms of its circuitry. Otherwise, PPM has an advantage of that the effect of noise in PPM is very less. One more drawback of PPM is the synchronization issues. If you observe carefully, this time information is present with respect to the reference point. Now, for example, if somebody is not able to keep track of this reference point, then there is no use of at what location the pulse is occurring, because the location of pulse makes sense only when it is measured from the reference point. If you measure it from any other point, it will not give you correct position, and hence it will not represent the correct information. So receiver must be in proper synchronization with the transmitter, and receiver must measure the position of the pulse from a very right time instant. So if there are any synchronization mismatch between transmitter and receiver, then the PPM signal will not be read properly. For example, in this demodulation process only, we have to generate reference pulses at reference time instant. If this reference time instant is not correctly known, then the reference pulses will be generated at some other position, and in that case the width of the pulse may not correspond to the position and hence to the original information. So there could be the problem of timing inaccuracies, and hence in PPM system we may have to send the reference pulse for the synchronization along with the PPM signal. Apart from that, one drawback, PPM is preferred because of its constant amplitude and constant width nature.